Hi, everyone. I am Maria Banks, and I was the project scientist, am the project scientist on Blue Ghost Mission 1. This is a bit of an eye chart, but I'm just thrilled to have had the privilege of working with all of these folks listed here and many, many more from our NASA payload teams, really incredible teams. So go ahead to the next slide. So I won't speak to this in detail in the interest of time, but there were 10 NASA-sponsored payloads that were science and technology demonstrations. And so I'm going to speak to each of these more as we go along, but you can see the variation in science and technology goals. Each one was selected individually, but they did find ways to collaborate together and enhance our science return. Go ahead to the next slide, please. So I won't say much because Joel said quite a bit about this already, but we did launch on January 15th. This is one of my favorite images. One of our payloads is the big long instrument sticking up. That's Lexi, our X-ray imager. The high gain antenna is next to that. And just above the Earth is a little white dot, and that's the moon. This was taken right before the TLI burn. Go ahead to the next slide, please. Our total transit time, including Earth orbit and lunar orbit, was 45 days. LOI was on February 13th, and this is another one of my favorite pictures, which was my first view of when we had arrived at the moon, which just was spectacular to see. Go ahead to the next slide, please. And Joel already showed this, so I won't explain it, but basically this is taken just as we were landing on March 2nd in Mare Crisium, roughly 58 meters from the edge of the original landing ellipse. Go ahead to the next slide, please. And I just put this in there. It's just a good example of some good press that we were getting. This is from the New York Times. And I was fortunate enough to be sitting in the operations center at landing. And my instinct was to stand up and slap a high five with the Firefly Aerospace my partner in crime there, the payloads coordinator, Farah, and just a demonstration of our two teams collaborating together and the success that was. So I thought I'd share that. Go ahead to the next slide. And this was also shown by Joe, Joel, another example of our different teams working together for success. These are the first images from LROC. These are the featured images that are online, actually. And especially that closest approach image just proved to be very essential to provide important context to understand the lunar environment that we were operating in, especially with that proximity to that 12 diameter crater there. You can see it blinking. Go ahead to the next slide. Okay, so let's dig in. Let's talk about payloads. So we'll start with the Lunar Planet Vac. So the video is playing over here. This is basically LPV. I'll explain the video as I go along here, but LPV collected and transferred and sorted lunar regolith particles using pressurized nitrogen gas, demonstrating a low-cost, low-emission solution, low-mass solution for future robotic sample collection. And this video is showing first the deployment of LPV onto the surface, and then that was the deployment. Now this is their first operation, about 5 seconds there. And they collected about 13 grams of regolith, including 5 grams of 2 millimeter scale rocklets. Successfully, you'll notice the lens was a little dusty at first, and then it gets cleaned off. And there was also a rock that got lofted about 2.5 centimeters in diameter. You'll see it in just another second. Put a good spin on it. The team named that rock Dwayne for Dwayne "The Rock" Johnson. So 1 second here, we can meet Dwayne again. There's Dwayne. Okay, go ahead to the next slide. Okay, so LUGRE, that was the Lunar GNSS Receiver Experiment, acquired and tracked Global Navigation Satellite System, GNSS signals from, in particular, the GPS and Galileo constellations. And it was able to calculate instantaneous navigation fixes both en route to and on the moon's surface for the first time. So this demonstrated that these GNSS signals can be used to support navigation, not only in cislunar space, but also on the surface of the moon. This was a partnership between NASA and ASI also. Go ahead to the next slide. RAD-PC was a radiation-tolerant computing system that mitigates the impact of single event effects through a series of novel fault recovery procedures. And RAD-PC was probably operated the longest on duration of all of our instruments, and it was verified solutions to mitigate radiation effects on computers. And hopefully this will help make future missions safer for equipment and more cost effective. Go ahead to the next slide, please. So a little bit of an eye chart on the left there, but it's just showing some of the results, especially for the radiation data that was collected through Earth's Van Allen belts. That's on the far left side of the chart there. In transit to and in lunar orbit, the middle part of the graph there, and on the lunar surface. And we also were able to operate RAD-PC through the solar eclipse and into the lunar night. And I'm happy to say that RAD-PC was able to successfully operate 100% of the time that it was on with no faults, on 100% uptime during the entire mission. Go ahead to the next slide. So EDS is the electrodynamic dust shield, which successfully lifted and moved lunar regolith from surfaces using just electrodynamic forces. So on the upper right-hand side, you see before launch 2 surfaces. The one on the left is glass. The one on the right is a radiator, a thermal radiator, sorry. And then on the bottom from left to right, you'll see just after landing, the regolith that collected on those surfaces. And then using, hi, sorry, I'm giving a talk. Oh, okay, thanks. Sorry, folks, I'm in a room that someone else just came in. So then after the cleaning event from their first operation, and then as you saw from LPV, they delivered quite a bit of regolith to the EDS. You can see quite an accumulation there. And then after extended operations, they were able to remove much of that regolith. So go ahead to the next slide, please. And so this video is playing. This is just their first operation. Okay, we can go to the next slide just to show you that there. LEXI is the Lunar Environment Heliospheric X-ray Imager, which captured X-ray images to study the interaction of the solar wind and Earth's magnetic field. And that's LEXI in that image there sticking up to the right. This is just shortly after landing on the surface of the moon. And the results are providing insights into how space weather and other cosmic forces surrounding the Earth affect the planet. They were able to get quite a bit higher volume of data than they were anticipating. So the team is still digging through that data. So stay tuned for more results on that. Go ahead to the next slide. The NGLR, the Next Generation Lunar Retroreflector, we were able to successfully range to that from lunar laser ranging observatories on Earth. Just within the first 24 hours on the surface, actually, from France, also successes from Germany and Apache Point, and even Lola has now successfully acquired a return from NGLR. And so the NGR is made to enable precise measurements of the moon's shape, the distance from Earth, and expanding our understanding of the moon's inner structure. And early observations are showing that results from returns are showing in comparison to the returns from Apollo 15 retroreflector by a factor as large as 17. Go ahead to the next slide. So SCALPS, the stereo cameras, for lunar plume surface studies instrument. SCALPS operated primarily during descent, but then ended up operating on the surface and then also in transit too, even imaged one of the burns, one of the LOI burns. And altogether, they captured more than 9,000 images, including during the spacecraft's descent there and on the surface. Go ahead to the next slide. So you see, go ahead and start the video. The long focal length cameras started operating at about 50 meters altitude. The short focal length cameras start at about 30 meters and then continue to the surface. I'll just let you enjoy this really fabulous video. Go ahead to the next slide. Go ahead. Okay, I'll try to wrap up real quick here. We had a lot of payloads. So there was the RAC, the Regolith Adherence Characterization Instrument. Go ahead to the next slide. The RAC had 15 slots with 15 different materials. This slot one is the titanium alloy. And then this is just showing one set of results. You can see we landed on March 2nd, but on March 3rd, there was suddenly much more regolith adhering to the surface that then cleared. And the team is just looking at these images and trying to understand this a little bit better. Go ahead to the next slide. I'm almost done here. 2 more payloads. So this is the LMS, the Lunar Magnetotelluric Sounder, which successfully deployed sensors to study the moon's interior by measuring electric and magnetic fields. It was able to characterize the interior moon up to depths of about 1,000 kilometers. This video on the right that you just saw go, that is one of the electrodes there it is, there goes one of those electrodes being deployed. And on the left is an image showing the mast of LMS. Go ahead to the next slide. All right, and this is our last instrument. This is LISTER, the Lunar Instrumentation for Subsurface Thermal Exploration with Rapidity. It is now the deepest robotic planetary subsurface thermal probe. It drilled and acquired thermal measurements at 8 depths and went to a total depth of roughly 1 meter, providing our first time demonstration of robotic thermal measurements at varying depths. And this is an image from SCALPS, just showing again the collaboration that our teams came up with, SCALPS providing a different vantage point of the drill. And so that was the drill already deployed. To the left of it, you'll see a squiggly line that is actually one of the wires from the LMS deployments. And on the next slide is my last video showing a LISTER drilling. And so this is its first deployment, and there you see the jets going, and it hits a semi-consolidated layer, and in a couple of seconds it'll hit a second one. There you go. And then it kept on drilling to about 30 centimeters where it was commanded to stop and get its first thermal measurements. So go ahead, the next slide is my last slide. I'll just wrap up. Yeah, so the surface mission extended through 1 lunar day and multiple hours into the night, concluded on March 16th, and it is the longest surface duration commercial mission on the moon to date. And so stay tuned. Analysis of the data returned from these instruments continues. And these are just some images of the lunar sunset and an image from the total solar eclipse on March 14th. Thank you.